Guys, today we're going to do the very last lesson for Unit 9, which guess what? It is the very last lesson for the entire year. Our next unit is just reviewing for our end of the year test, the EOC. So pretty exciting, okay? So let's get going here. So this is today's unit. It's going to feel like we're taking a step away from exponential functions. So just don't worry about it. You've actually seen this a little bit already. At the beginning of the year, we did what's called arithmetic or arithmetic functions. It was sequencing where we would say, okay, position number one is this number. So if I'm multiplying by 3, then position number, well, if I'm adding 3, position number 2 will be this number. If I add 3 again, position number 3 is this number. If I add 3 again, position number 4 is this number. We're going to be doing the same type of thing today, only today we're going to be doing multiplication. That's called geometric sequencing. So let's get started on it. It's pretty easy stuff. It's going to look weird, but it's pretty easy stuff. So geometric, let me write that down there. Geometric sequences are mathematical sequences that do not change by adding or subtracting, but instead each term is multiplied by a common factor to get to the next number. If you're multiplying by a fraction, it's going to feel like you're dividing, though at the same time. So sometimes you're going to be like, hey, I'm dividing, but actually we're multiplying by a fraction. So the amount that each term is multiplied by is called the common ratio. When we did arithmetic sequences, we called it the common difference. And now we have the common ratio because we're multiplying. The common factor can be found by dividing any term by the previous term. Or if you're going the opposite direction, it's going to be multiplying. So again, multiplying, dividing, multiplying, dividing. So let's see what that looks like. So here we have a bunch of terms, and I need to find the common ratio. So what I'm going to do is I'm going to take a term like 64, and I'm going to divide it by the previous term. So 64 divided by 16 is 4. And I can test it by doing the next one and seeing if I get the same number. And if I check all of these, I get 4. So my ratio is 4. Now, if you know, dividing by 4 this way is the same as multiplying by 4 going the opposite direction. So I can actually figure out the next 3 terms. 64 times 4 is 256. 256 times 4 is 1024, 1024. 1024 times 4 is 4096. So that was pretty painless. Let's go to the next one. All right. So let's see. I'm going to divide 1/3 by the previous term. If I take 1/3 and I divide it by 1, I get 1/3. If I take 1 and I divide it by 3, I get 1/3. If I take 3 and I divide it by 9, I get 1/3. So the next 3 terms are going to be 1 over 9, which, by the way, I'm going to do the opposite. I can multiply by the 1/3. So I get 1 over 9, 1 over 27, 1 over 81. So I was dividing to the left, multiplying to the right. Because remember, we're always looking at the previous term to figure it out. Let's go to the next one. So now this is taking us back to arithmetic, and we're doing a comparison to tell, well, which one is it? So I'm going to look at the first one, and I'm going to take the 32, and I'm going to divide it by the 64. 32 divided by 64. If I put that in my calculator, I'm going to get 0.5. If I take the 64 and I divide it by the 128, I get 0.5. If I take the 128 and I divide it by 256, I get 0.5. So it's my ratio. which means it's going to be geometric. So let's test the next one. If I take 18 and divide it by 12, then I get 1.5. If I take 12 and divide it by 9, I get, no, okay, 4. Let's go the other way. Let's try this. Let's try a common difference. So adding and subtracting. I can add 5. Okay, that's not working either. So this is neither. Nothing's happening on this one. Let's try the next one. All right, the next one I can see pretty obviously that I'm adding 5 all the way across. So the difference, my D, is 5, and this is arithmetic. Okay, next one. So 27, if I take 27 and I divide it by 9, I get 3. If I take 9 and I divide it by 3, I get 3. If I take 3 and I divide it by 1, I get 3. So here it's a ratio. Whoops. Ratio is 3, and this is geometric. So this one's just identifying, seeing what is the pattern, noting that. Okay, now, please don't get caught up in what you see right here. It's the same thing. It's a rule, and then it's the rule written like a function. So it means the same thing. It's kind of like saying if I wrote y equals mx plus b, you know that as a linear equation. But if I say f of x equals mx plus b, it's the same linear equation written as a function. So it's the same thing. So don't get caught up in that. The most important thing that you need to notice is figuring out what is the first term, or how do I identify that, and then what is the ratio. Okay, this is all going to be geometric. So I'm going to look at here, and I'm going to note that, let's look at right here. The way this is written, this is always going to indicate what number in what position we're talking about. And I don't know if you remember doing something like this where we would write, let's see, I don't have room really to write it, but when we did a thing like this, where we said position number 1, position number 2, position number 3, position number 4. So when you see f of 1 equals 3, it's telling you that the first position is 3. So I'm going to put a 3 right here. Now this part of the function is telling you what we're going to do with 3 or with the previous term. We're going to multiply it by 4. So this would mean the second position we have 12 because 3 times 4 is 12. In the third position we have 48 because 12 times 4 is 48. And I can keep on going with this. 192, 768. All right, now let's look and see what is another way that you might see this written. So here again, this is telling you what position number 1 is. A sub 1 is position number 1. And this is telling you what the ratio is. So we're going to take that number and we're going to multiply it by 1/4. And I get 4. So position number 1 is 16. Position number 2 is 4. Position number 3, I'm going to take that 4, multiply it by 1/4. I get 1. And we're going to keep doing that for each position. Okay, let's move on. And those are the two things that you're really going to you want to focus on understanding and knowing, is how to read the function and to say, okay, what's the first term going to be and what's the ratio going to be. Let's move on to the next one. Okay, now we don't have the rule. Now we have the sequence. So it's up to you to figure out what is the first term and what is the ratio. We're not going to actually write the rule here. We're just going to look at those two things. So I can see pretty easily what the first term is for number 4, and the first term is for example B, 4096. All right, that was easy. Now we're going to figure out what the term is. So I can look and see if I can see a pattern. I see here that it's times 5. Now, if I went the opposite direction, because remember, it was a term divided by the previous term, and I get 5. And if you go the other way, it's still 5. So the way it's taught is always looking at the previous term. So either way you want to go, however your brain works, that's the way you should go. But it's easy to figure out what the ratio is. The ratio is 5. So let's look at this one right here. I'm going to take 8 and divide it by the previous term. I get 1 over 8. And if I take 64 and divide it by the previous term, I get 1 over 8. So the ratio is 1 over 8. Now, if I went to the right and I multiplied by 1 over 8, it would actually be dividing it. So again, think of the term divided by the previous term, or work your way the other direction. I hope that was helpful. These are this example number 4. These are the two main things you want to be able to figure out on your own. And then if you're looking at a function, for example 3, you want to be able to look at a function, be able to tell what is that first term and what is the ratio. It's going to be easy. I'll see you later. Bye-bye.